day everyone and welcome to these lectures on physico-chemical processes for wastewater treatment. So, in the last few lectures we studied regarding the case studies with respect to wastewater generation and their treatment in various industries, and we studied regarding these treatment strategies in sugar industry, distilleries, fertilizer plants and petroleum refining units. Now, today we will be discussing the recently last 2 decade developed strategy, and this particular thing is called as common effluent treatment plant. So, in this case actually the effluents collected from different industries where some primary treatment may have been done earlier, that is further treated in a common effluent treatment plant. So, this is commonly called as CETP. So, we will try to understand the CETP and how they are functioning, how they have evolved and what are the advantages and constraints with respect to use of CETP. Now, already the government of India is pushing and various with respect to minimization of environmental pollution due to small and medium scale industries. The cleaner production technologies are being implemented, new type of waste minimization techniques are being implemented or encouraged. Besides all these techniques, there is a new collective wastewater treatment strategy which is being now used across the country at various places where cluster of industries are there. That means, wherever we have special economic zones or wherever we have clusters of industries. So, at those places the CETP is being made and the CETP, which is a centralized facility for that industrial cluster, is being considered as a viable treatment solution. And actually the use of CEP helps in overcoming the constraints which may be associated with respect to effluent treatment in small and medium enterprises. So, it is there till 1990 only one CETP was functional in Hyderabad. After that the Ministry of Environment, Forest, or nowadays it is called as Ministry of Environment, Forest and Climate Change. So, that is pushing for lot of CETPs and using CETPs for effluent treatment which are getting generated in these small and medium enterprises. Now, the government of India initiated an initiative financial support scheme for CETPs to ensure the growth of small and medium entrepreneurs in an environmentally compatible manner. Now, the provisions of the scheme for fund support are given here as like state government will give subsidy 25% of the project capital cost, central government will give the similar matching grant of 25%, loans from financial institutions will be available. Also the SMEs, the small and medium entrepreneurs or enterprises, they have to give around 20% of the project capital cost. So, this is how these CETP are being implemented. Now, the concept of CETP was adopted as a way to achieve end of pipe treatment of combined wastewater to avail the benefit of scale of operation, because if individual industries actually start treating the water, so they will require lot of land space. Beyond that they will require lot of energy input and cost input. So, that will cause problem to them because the amount of water generated in these industries may be smaller. Now, if we combine all the water, so the amount of water will be high. So, the treatment still the treatment can be done, but the cost thing will come down tremendously. So, to avail the benefit of this, the concept of CETP has been adopted. Now, in addition, CETP also facilitates the reduction of number of discharge points in an industrial estate. So, if we have industrial cluster and each and every industry has its own discharge point. So, it is difficult to manage, enforce the various norms which have been made by the government, and but if the CETP is there, so we have only one discharge point and that can be easily be monitored or enforced. So, this is there. Because of the this concept of CETP and its wider uses, a large number of CETP have come up in the country, and the number here may be only already it may have changed a lot. So, it is continuously the number of CETPs in the country are increasing, and a large number of CETPs are being made also. Now, we can see here that a zone wise status of zone wise CETPs in the country is given here. So, all the states like Andhra Pradesh, Gujarat, Haryana, Maharashtra, they have large chunk of CETPs. Similarly, Karnataka, Uttar Pradesh, Tamil Nadu, all these are also having large number of CETPs and a large more number of CETPs are being built. Now, there is these CETPs can treat homogeneous and heterogeneous industrial wastewater. So, how they are working, let us try to understand. So, suppose we have a cluster of industry. So, we are just marking it here. So, we have a cluster of industry. It is possible that one of the industry may be textile, okay, another may be pharmaceutical, okay. Then there may be another industry may be there which may be producing some other type of chemicals, maybe food processing industry, okay. Similarly, another industry may be there where other types of products may be formed, including like surfactant, detergent, etc. So, these are different industries. Now, each of them is producing may have to adopt a different treatment strategy for treatment of their wastewater. Now, what is done is that all these industries are told that they have to adopt some treatment strategy. So, this is called ETP or primary treatment strategies in each of the plant. So, each of the unit will be having some primary treatment, we can call as PT also primary treatment, or many of the industries have to adopt more treatment. So, it may be up to ETP also. So, this treatment has to be done. After that, the water which is generated, so they do not go up to the standards, they only perform primary treatment, so that the characteristics of the effluent which are generated from all these industries, they are merged together and we have a larger CETP which is used and which actually treats the effluent. So, this is the strategy which is adopted. So, we have only all these industries have to use primary treatment, or it is also called as effluent treatment plant, but it will be having only minimum number of units only. So, only some basic units will be there like aeration unit, coagulation, flocculation, etc. Depending upon the type of wastewater being generated, they may have some additional treatment also. So, they will control the pollutant which is coming from that particular industry which is peculiar in nature. Like for the surfactant industry, their primary treatment unit or ETP unit will try to control the surfactant. From pharmaceutical, they will try to see that antibiotics and other types of pharmaceutical drugs which are getting generated typical, they may be removed beforehand. So, this is how that strategy works. Similarly, it is possible that a treatment plant may be there, a industry may be there which is like electronics industry. Now, this electronics industry is there. So, we may think that okay, they will not require any treatment, but actually in actual condition they may still be requiring some treatment of wastewater. Wastewater still will get generated here, because they may be having suppose 1000 workers in their industry. So, under that condition they will be generating municipal type of wastewater. So, that wastewater still has to be treated. So, they may have to, they may install some sewage treatment plant in place of effluent treatment plant. Still they will have to install some plant, or if their characteristic is not of that much bad quality, so it may be eliminated and water may directly go into and get mixed with this water, and then it will go into the CETP, where full treatment as per the discharge standard will be done. So, we have this cluster which is heterogeneous industrial cluster. So, this will be heterogeneous industrial cluster which is there. Similarly, there is a possibility that in any industrial cluster only one type of industry is there. So, suppose all the industry are pharmaceutical. So, we have pharmaceutical 1, PS pharmaceutical 2. So, all the industrial units are of pharmaceutical industries. Similarly, there could be like I have seen myself that in one of the clusters only electroplating industries were there. So, all the industries were electroplating industries. So, I am writing just EP. So, all the industries are electroplating. So, under that condition there may be a thing that they do not require any treatment. So, all the water, if they have the same characteristic, the water may directly go and get combined and it may go into the CETP. So, this is possible. If their characteristics are different, some primary treatment still may have to involve be used in some of the industries, other industries may not use. So, we have the possibility of homogeneous industrial wastewater treatment. So, all the industries are homogeneous in nature, all are pharmaceutical, all are electroplating, all are textile unit only. So, depending upon that the wastewater will getting generated and this will go into the CETP. So, this is there. Now, understanding what are the advantages of CETP. So, advantage is that it facilitates the economy of scale, because we are treating large amount of wastewater. The cost in terms of rupees per liter will go down very quickly treatment, because we are only treating large amount of wastewater as compared to small amount of wastewater. So, the cost of pollution abatement will be much lesser as compared to if the treatment is being done in the individual SMEs. Now, also many small scale industries, they cannot build the effluent treatment units because their space is very less. So, they may be built in a very small space. Now, they do not have the space for building these treatment units. So, the lack of space issue can be taken care of in the CETP scheme. So, this is there. So, CETP can be planned in advance to ensure that adequate space is available, including plan of expansion also if possible in later on. Now, it is also possible that the actual treatment plant homogenization of water is being done, wastewater which is getting generated, because all the wastewater is getting mixed. So, we have a homogeneous wastewater which is coming. In this case, we have to take care that some peculiar pollutant or nothing is coming out from these industries, which is getting mixed with other industrial wastewater and making the under industrial wastewater untreatable. So, that aspect is certainly there, but still we are making the wastewater homogeneous in nature. So, the treatment becomes easy. Now, relatively better hydraulic stability is also there. We can professionally control the treatment and it can become affordable also. So, certainly. Now, the concept of CETP facilitates small scale units which often cannot internalize the externalities due to control of pollution. So, all these SMEs become free in a way with respect to thinking of what is the pollution that they are doing, and so these aspects they are free. Now, this eliminates multiple discharge point also in the area, because all the industries within that cluster are discharging the effluent only to the CETP, where further treatment is done. It also provides opportunity to improve the recycling and reuse, because the wastewater after that can be used in the whole industrial cluster for gardening, for irrigation, etc., and also for reuse in the industry themselves. So, they can also take back the water. It also facilitates better organization of treated effluent and sludge disposal things in the CETP. Now, what are the problems and constraints with respect to use of CETP? So, there are certainly advantages, but there are some problems and constraints also. Now, the consistency in compliance to the prescribed standards by the CETP is constrained by many reasons. Now, these CETPs, they are operating on one size fits all basis. So, that means they always expect the water to be some of homogeneous nature. Now, any time if there is some problem in that industry and the ETP of that particular industry which is generating some peculiar pollutant is not working well. So, under that condition the operation will be affected. Also, since all the industries may be discharging different quantity of wastewater. So, if all are levied the same amount, or the industry have to give the same amount to the CETP for the treatment of their wastewater, then they may cause operational issues. So, lack of access to the capital investment, sometimes working capital, specialized technical skills with respect which is required in the CETP, and inconsistent effluent quality. This is the most important parameter, because if any industry is not properly doing the pre-treatment, in particular in a heterogeneous CETP, then there is a lot of problem may happen. The treatment thing can totally go off in the CETP. Now, improper management of treatment unit at a common facility varies with the nature and scale of the industries. Now, if more number of industries are getting added in haphazard manner, so without any proper planning, then the CETP may not work properly. Also, no provision to tackle the fluctuations in the pollution load, because this is very important, the inconsistent effluent and the fluctuation in the pollution load and the quantity. So, from the individual member industries. So, if any of these issues are there, then the problem will happen with respect to treatment in the CETP. Now, no separate treatment units to deal with the hazardous and toxic effluents which are generated in some of the industries. So, that may be also one of the problem and constraint area. Categories of effluent generating industries already we have discussed. So, treatability of mixed effluent streams generated from various types of industries is a complex issue. It is not very easy, with respect to providing a treatment scheme and for its operation. CETPs can be classified based upon combination of industries. So, homogeneous industries already we have discussed. So, we may have a textile cluster may be there, a tannery cluster may be there, electroplating cluster can be there. So, this is homogeneous industries. So, all member industries fall in the same industrial sector and involved in the similar operation. In the homogeneous industry cluster, there may be different industries which may be there. So, heterogeneous industries will be there. Now, while for homogeneous industry the quantitative and qualitative fluctuations may be within the predictable range, because their process operations are similar, but in the heterogeneous industry there will be highly fluctuations may be high as compared to in the homogeneous industrial cluster, and because of that there may be lot of issues which may be there with respect to treatment of combined wastewater in the CETP. Now, the qualitative and quantitative fluctuations of effluent, in particular with respect to heterogeneous industrial cluster. The quantitative fluctuations specify the volume of the equalization basin. So, that data is required. So, based upon that only the equalization basin of the CETP can be designed. So, in this way we can properly operate the CETP. The modular design of effluent treatment plants is an important aspect of proper handling of varying hydraulic load, because these industries, some of these industries may be seasonal in nature or they may be operating in a batch mode. So, this way these industrial, the volume may fluctuate a lot. So, that means the quantitative volume of water which is coming, that will be varying a lot, and the CETP needs to take care of these fluctuations. Now, the capacity of equalization or holding tank must be properly determined to homogenize the influent characteristics, and it will help in avoiding the shock loads that will be going into the CETP. Then the quantity of effluent, the effluent quantity can be assessed based upon the product details furnished by that individual industry with a comparison from literature values and from the water balance submitted by the individual industry to that particular state pollution control board or that particular industrial cluster organization. So, in their consent application. So, from that we can get to know that how much amount of effluent they are likely to generate. Also, with respect to capacity, there is always with industries some idea is already always available that how much liter of water they can discharge at maximum. So, from there also we can get to know that what will be the quantity of effluent that will be generated. Also, while arriving at the size of CETP with respect to flow, the various unit operations considered shall be sized and layout is prepared to add any additional units in future depending upon the projected growth rate of that industrial cluster. So, that is possible. So, with respect to flow, it is possible that during the initial design the flow may be less, but it is being thought that with time a number of more industries are going to come and they will still discharge their flow into the CETP. So, that additional or future expansion should be properly taken care. Now, with respect to flow rate is important in determining the size of CETP. Minimum and maximum flows should be computed as they decide the hydraulic computations as well as the size of pipe distribution. So, because the pipes, channels etc. are being used to take the wastewater from different industrial industries to CETP. So, we should have a tentative idea of minimum and maximum flows. Anticipated future increase should also be incorporated. The temporal flow variations that may be there, they require use of equalization ponds to allow a constant flow rate through the downstream processes. So, we have lot of uses of equalization pond in CETP with respect to use of CETP in any industrial cluster. Now, mixing of wastewater includes sewage often. So, already told example is suppose any electronic industry is there. So, that may not generate a highly industrial wastewater, it will generate sewage only. So, this also we have to see that mixing of wastewater including sewage often helps in reducing the concentration of pollutant, but we should have a tentative idea that how much flow rate of sewage will be there. Now, in addition to flow rate, the quantity of water that will be generated, the effluent characteristics is very important. The physical characteristics of effluent in designing the CETP which are very important include temperature. So, temperature of effluents is useful in indicating the solubility of oxygen which affects the oxygen transfer capacity in the aeration equipments. So, that is there. Then color and odor, If any, suppose any textile unit is there, so that will discharge lot of color. Similarly, any other unit which is causing lot of odor, so that also we should know. So, if color and odor is there, it indicates the colloidal portion and needs a specific treatment, maybe in the that industry itself. So, that has to be seen. Similarly, total and volatile suspended solids. So, they may be including the both suspended and dissolved solids. So, their estimation is very important, and based upon that the CETP has to be designed. The chemical characteristics of the combined effluent or individual effluent, the pH in particular. The biological treatment units as CETP are highly sensitive to pH. So, if any industry is discharging some water, wastewater with highly acidic condition or highly basic condition, so we have to cross check that, and we should be seeing that the water which is going for treatment, in particular in the biological treatment units of CETP, it should have a highly homogeneous pH in the similar pH range, otherwise it will totally damage that biological treatment unit. So, it is very important that we should cross check this. Acidic effluents may also cause corrosion related problems in the pipelines as well as in the CETP itself. Now, many effluents contain lot of carbonaceous substrates. So, carbonaceous constituents are measured by BOD, COD, TOC, etc. These parameters already we have studied. So, this idea should be there that what is the load that is coming to the CETP. Now, COD is becoming more common parameter in most of the current design models. So, this COD is more used, but BOD gives that idea that how much treatment is possible in the biological treatment units. So, if BOD and COD or their ratio is known, so it gives larger idea that how much what should be the treatment strategy, whether we require tertiary treatment, and what different types of tertiary units will be required. So, that will be known from both BOD and COD value. COD value will always be higher than the BOD, this is well known. So, this COD estimation of BOD and COD is very important for design of CETP. Similarly, TOC is another parameter which is nowadays being used in place of COD, but it gives a tentative idea that how much total organic carbon is present in the water, and through this analysis we can know that we can control the day to day operations of the treatment plant itself. So, this is easy to estimate, but we require sophisticated instrument for measuring the TOC values. Now, what types of toxic metals and other type of compounds are present in the combined effluent which is getting generated from these industries. So, if some heavy metals such as chromium, copper, etc. are present, so they will determine the precipitation of biological, they will determine that what will be the efficiency of biological treatment or how to remove these metals beforehand. So, various considerations may be there with respect to choice of treatment if these toxic metals and or other compounds are present in the water. So, this is there. Now, before CETP, always it is better to minimize the waste in the industry itself. So, waste minimization strategies in the all these SMEs is very important. So, the basic principles of waste minimization considering the order of acceptability are as follows: avoiding or eliminating the production of waste. So, this has to be done by the industry itself. Nowadays, in many CETPs, they are charging the industries with respect to that how much quantity of water they are giving and what is the characteristic of the water. So, if they are doing waste minimization, so the CETP will charge less as compared to in the condition when they are not doing any waste minimization. Along with the quantity of water, the characteristic of water is also defined in different ranges. So, they are levied with respect to that rupees per unit COD, rupees per unit some particular key parameter. Now, if any industry is discharging some highly objectionable pollutant to CETP, the amount of penalty levied on that industry may be higher. So, any parameter which affects the working of CETP for that industry, the charge levied may be very high. So, like suppose if any industry is discharging some compounds or chemicals which may hamper the operation of CETP. So, that particular industry may be charged very heavily. The examples could be surfactant or very low pH wastewater or very high pH wastewater or any other parameter as well. So, it is very important that these industries should minimize the waste by themselves. So, reduction and minimization of waste within the industry is very important. It helps the industry also and it helps the CETP also with respect to its operation. Now, in each of the industry some pre-treatment may be required. So, in the initial times the CETPs were considered to be the sinks of all the raw effluents from the industries, and because of that they suffered a lot of problems and they did not know that what pre-treatment strategies have to be followed at the industrial level or at the CETP level. Now, in many industries the industry themselves have to do the pre-treatment. So, scientific understanding of complex characteristics of the wastewater generated in different industries have helped in understanding that what type of key pollutants need to be removed beforehand. So, this way the pre-treatment has to be done. So, the inlet effluent standards have been set for many CETPs. So, they will be taking effluent with some particular characteristics, and if the variation is way beyond that, the amount of charge which will be there for that particular industry will also vary. So, this inlet effluent standards were brought in with an understanding that suspended solids biodegradable material will be removed at CETP, but other type of things have to be removed beforehand. Any peculiar compound or chemical have to be removed beforehand in the industry itself. Now, the pre-treatment industries, effluents from industrial processes require some form of pre-treatment prior to sending the effluent for further treatment at CETP. This is mainly required when wastewater is carried through gravity lines to minimize the corrosion and clogging, to prevent the reduction in biological treatment process efficiency due to any toxic constituents or otherwise. So, that is why the pre-treatment has to be done in the industry itself. Now, the pre-treatment standards for sulphide, sulfates, pH, they are highly objectionable and they have to be treated beforehand. So, either they have to be treated in the industry or some industries can mix up them together before sending them to the CETPs, but this treatment has to be done beforehand. So, this is there. Similarly, in the pipeline there may be formation of anaerobic condition may be there prevailing. So, it may lead to formation of hydrogen sulfide that may lead to the fire accidents, hydrogen sulfide, methane etc. may get formed. So, all these aspects have to be taken care in the pre-treatment itself. Now, before sending the effluent to the CETP, segregation of effluent streams at the individual member industry is also very important. So, effluent streams could be broadly segregated by combining appropriate based upon their suitability for a specific treatment. So, effluent at individual industry levels, they may be classified into different high TDS, low CAD or high COD, low TDS. So, the treatment strategies could be different in the CETP for such wastewater. So, segregation is very important. Now, in organic chemical industry similarly, there may be different types of wastewaters which may get generated. So, the when the member industries of CETP comprise of chemical industries or multiple industrial categories, the complexities with respect to the operation and maintenance is very high in the CETP and they demand very high specific skills. So, it has been felt that the need to have some qualitative assessment of their effluent streams. So, all the industries, member industries need to perform this qualitative assessment and they must segregate the effluent generated into the streams which are like high inorganic streams, highly concentrated effluent or non-degradable or toxic effluent, non-degradable compounds containing effluent. Similarly, it may be mixed which where both organic and inorganic streams are there. So, this type of clustering segregation of different effluent stream is highly important before sending them to the CETP. Now, these are some of the ideas with respect to depending upon that what amount of water, what amount of COD or TDS is there. So, we may use different types of units. So, some may be having the treatment has to be done in the ETP, some this will be the last step. So, domestic wastewater etc. may go directly depending upon the volume, the COD and TDS. So, before sending the water to CETP etc., some forced evaporation or incineration may have to be done later on depending upon this. So, we can see depending upon COD, depending upon volume, depending upon TDS. So, any treatment may have to be done beforehand, afterhand. So, segregation has to be done before properly using the CETP. Similarly, for tanneries we may have different choices like solar evaporation plants, chrome recovery unit, some ETP beforehand before sending to the CETP. Similarly, for textile industries lot of possibilities are there, in particular because the textile industries may be some industries may be generating dye bath effluent only, other may be generating only washings. So, depending upon the requirement they may have different treatment strategies and then the further treatment in the CETP. So, this is there. Now, once the wastewater has been generated in different industries, so it has to be taken to the CETP. So, the conveyance system which is there, that plays an essential role in cost effectiveness of the treatment besides the ease in plant operation. Now, during this the modes of collection of effluent from individual industries to CETP, generally it will be preferred to have pipes, open channels, tankers are less preferred, but if the gravity flow cannot happen or if the pipes and channels have not been laid, then the tankers can be used or we can have a combination of any of them for conveying the water from individual industry to the CETP for further treatment. Now, in the CETP the inlet effluent quality standards may vary. So, these are the different standards which have been set. It may vary from CETP to CETP whether it is heterogeneous, homogeneous. Then similarly, after treatment the treated effluent quantity from the CETP should always comply to the norms set by the Government of India. So, this has to be met, and whether the discharge from CETP is going for inland surface water or for on land for irrigation or into marine coastal areas, that will depend. Generally, from industrial clusters they may not be allowed to discharge any wastewater also. So, they have to recycle and reuse the water itself, but these are the some of the standards so which have been set. So, some of the references which have been used in the present slides are given here. We will in the next lecture what we will do is that we will try to understand that what are the different strategies which are possible with respect to treatment in the CETP. Also we will compare the different treatment strategies with respect to their application for treatment of various types of wastewater, that we will try to summarize in the next lecture, which is the last lecture of this series of lectures with respect to treatment of physico-chemical treatment of wastewater. Thank you very much.